Okay guys, and the second video of this unit is the same thing, but I'm doing two examples in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. Again, we did many units on all the forms of a line. We had to graph them, we had to find the equation of them way back in January and February and into March. So here we go. Let's look at that first line, and let's just write down some information that we know. I know that the slope is -1/2, because that's what's written in front of x. Remember, m is the number in front of x. And my y-intercept is your b. It's -2, so it's the point 0, -2. So remember, in this form, you first plot the point, your y-intercept. So 0, -2 is right here. And then I use my slope of -1/2. Come on and focus. So that means I can go up 1 and to the left 2. I can also go down 1 and to the right 2. That's it. Because it's just a less than and not a less than or equal to, this line is dotted. Just give me a minute here. Okay. I am now going to test 0, 0, because 0, 0 is not on this line. So I'm putting 0 in for x and y right here. So I'm going to have 0 is less than 0 minus 2. 0 minus 2 is -2. So is 0 less than -2? No, that's false. So because that's false, I shade on the side that does not have 0, 0 on it. 0, 0 is here. It's above the line. Because my inequality was false, I shade on the other side, which in this case is below the line. Okay, next line, still in slope-intercept. Just write down some information. Our slope here is -3 because it's the number in front of x. My y-intercept is 0, 3 because that is your b. So I start by plotting the point 0, 3. My slope is -3. For those of you who need to do it, you can write that over 1. So that means I can go from my y-intercept, I can go down 3, 1, 2, 3, and to the right 1. Or I can go up 3, 1, 2, 3, whoops, and to the left 1. This line is going to be solid because it's equal to. Okay, I'm going to connect this. Oh boy, I'm a little off. That's what I get for not having graph paper. Okay, now let's test a point. 0, 0 does not go through my teal line here. So I'm putting 0 in for x and y. So I'm going to have 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3? Yes, it is. So that means I shade the side that has 0, 0 on it, which is to the left or below. So notice I don't go crazy with my shading, especially people who like to write or color things in darkly. You might want to wait till the end because you're trying to see where they overlap. So this one might be a little bit more difficult to see, but remember the solution to this is where your two colors cross. So maybe I would extend the green maybe for you to see some more. So where do your green and purple overlap? I'm also going to actually extend out my purple line. Okay, I'll even do my answer in a different color. I'll do it in blue. I don't know if that's going to help. So the teal and the purple, they overlap right here. Coloring it in darker. Please color your solution in darker so that we know that you know what the answer is. Then it's going to ride along that teal line. Technically it goes all the way up to the line, but there's my answer. So any answer, any point in the shaded area would be a solution. Also, any point on the teal line would be a solution. But I'd like you to stop and think about why a point on this line here would not be a solution. That's because it's dotted. So again, our answer, we'd like you to bold them in so that we know that you know what the solution is. We also would expect to see work here. If you're looking for full credit on your assignments, we would expect to see similar to the work here that I have shown out. Okay, and the last one is kind of another special case that I wanted to look at. So your first one, it's still in slope-intercept form. Your slope is -1 because it's the number in front of x. That's a -1x. And your y-intercept your b is -1, so your y-intercept is at 0, -1. So there's my y-intercept, 0, -1. If you need to write the slope over 1, you can. So that would be down 1 and to the right 1. You could also go up 1 and to the left 1. It's greater than, so it's going to be dotted. So bear with me one more time. Okay, now I need to test 0, 0. 0, 0 does not go through it. So I'm putting 0 in for x and 0 in for y. So I'll have a 0 here and a 0 here. So I have 0 is greater than 0 minus 1. Is 0 greater than -1? Yes, it is. So that means I shade on the side that has 0, 0 on it, which is above. Okay, why I chose this second example of slope-intercept anyway is this one right here. X is less than 1. I did some of these when we did just regular inequalities last week, but I want to refresh your memory. Remember, this is really the equation x equals 1. That's a vertical line. As a reminder, x equals a number is a vertical, I can't spell, V-E-R-T-I-C-A-L. I can't even spell, V-E-R-T-I-C, vertical line. There we go. And y equals just a number is a horizontal line. Okay, so x is less than 1. That's really the line x equals 1. It's going to be dotted. It's a vertical line through 1. Okay, and so it's looking for all numbers less than 1. So that would be to the left of it. If you put in 0, 0, you would find that it's a true statement. 0 is less than 1, so you would shade to the left. So again, now you need to see where do the purple and the teal overlap. And that is in here. Again, the lines continue on forever in all of these, and the shaded area continues. This is just what's on our graph. So our solution is the shaded area. Okay, cool, my pen stopped working. For this example, both the lines are dotted, so points on either line would not be a solution to the system in this case.